Uber movement provides anonymized data from over 2 billion of Uber trips to help urban planning and city planners around the world to better understand the traffic patterns of their city.
Welcome to Design Drives, your audio experience about what, how, and why design drives things forward. A podcast hosted by Sebastian Gier, together with forward-thinking design practitioners from around the world. Enjoy the episode.
Shan is combining the arts with science. She is the founding member of Uber's data visualization team that not just spun off open source tools for designers to explore generative map visualizations, but also work closely with cities to use the data in urban planning. Super fascinating in the way she frames the design process, but also her background, from generative design in architecture to generative design in the digital space at MIT, while combining these with a strong interest in science. A perfect fit for design drives, Shan does design that drives transparency and decision making, but also enables awareness for people and makes complex issues understandable for everyone by creating stunning visualizations. Hey Shan, welcome to the podcast.
Hi, Sebastian.
Yeah, super happy to have you on the podcast. So, actually, we both spoke at a conference last year in Munich called Push Conference. We didn't manage to meet, but I had the chance to see your talk and directly saw a link between what we are doing at Design Drives and your work, essentially. So, what I think would be very interesting to hear from you and also for the audience would be your way getting into design, your background, have a quite interdisciplinary background, which basically enables you and empowers you to do quite unique work and projects.
I did my Bachelor of Architecture in China and then actually did my Master of Architecture in the US. And then as I was studying architecture, I got very interested into this sort of design practice called parametric design. And for those of you that are familiar with this project, it's basically how architect can use software to write algorithms that generate generate 3D models. So that's a simple description. And then I was very interested in just writing a couple of lines of code to manipulate the shape of my architectural design or the building space.
Interesting.
And then I find that whole process very interesting. And then that's kind of got me interested in learning programming, learning to write code, and kind of that's a natural introduction to computation.
That's fascinating. Coming from generative design and architecture, which programs were sort of the same programs than you use now in design, or completely different ones in architecture?
In architecture, you use there are a couple of ways, a couple of softwares. I think the most common one is a Grasshopper with Rhino. Grasshopper is a visual programming language that allow architects to tweak different parametrics and then generate shapes. And there's other ones that I was using at the time. There were CATIA, CATIA, and digital processing. Both of the software are for BIMs, building information modeling. So you use those software to embed information like the weight or the length, any kind of metadata into your 3D models, and you were able to use that software to generate your final architectural drawing.
And is it the software used at the moment, or used at MIT afterwards to working that out in design and computation? Were it the same software you were using, or different ones?
There were different ones. So at MIT, when I was studying design, so the ones I just described was the one that I was using when I was doing my master in architecture.
Yeah.
And then I started the design computation program at MIT. While I was at MIT, I actually shifted my focus a little bit. Instead of just doing parametric or generative design, I shifted a little bit into urban informatics. So I was actually writing JavaScript. I was building front-end applications to better visualize data in for urban studies. So that's kind of another transition when I was at MIT.
Interesting. So that was your focus during MIT, combining basically your knowledge.
Yes.
Would you call yourself a designer then? What you do at the moment, because it's so linked to so many disciplines,
Yeah, I will say there are many different words for what I do. There are like creative technologist is
Yeah.
one of the word, or data artist is something I like to call myself. So basically, something that combine both technology and design. I think that's the better description of my role.
And then after school, you joined Uber straight from school, I think, correctly?
Yes. So as I was at MIT, I on the side of doing my design computation degree, I started being a researcher at the Sensible City Lab. So the Sensible City Lab is a lab that doing a lot of urban informatics studies, urban visualizations, smart cities, learning how to use data to better help city planners and urban study urban designers to understanding how cities works. So I was a data visualization researcher at the lab for about a year or two, and then after I graduated from MIT, I started at Uber being the data visualization engineer.
Interesting. And what was your motivation joining Uber?
At that time, so I think it was about 4 years ago. That's when I graduated MIT. I went to career fair. I knew what I want to do is really something about visualizing data, help companies better understand their data and then shape their product. So I kind of have this drive to look for companies that has a lot of data and don't know how to do with it at that moment. Uber 4 years ago was still a pretty young startup at the time. And then I happened to met the head of data science from Uber. And I had a great conversation with him. He was showing me this huge dashboard at that time that they're trying to visualize like cars on the road, and then it's immediately reflected to what I was doing at MIT, the Sensible City Lab. So it kind of become a natural fit, and then we both feel like Uber, for me, Uber is a great company that has great potential to use my data visualization skills. For Uber or the head of data science manager, he felt like he can use my skill set to help his engineers and his data scientists to better understanding and visualize their data. So that's the beginning of everything.
Yeah, and during the conference, you were also saying you were basically the founding member or one of the first members of that data visualization team, correctly?
Yes, I like to say that I was the data visualization team 4 years ago, because I was the very first person that started to doing data visualization at Uber when I first joined. And it's an interesting journey because when you first join a company, saying that you're a data visualization person, they don't exactly understand what you do. I remember when I first interviewed at Uber, the official on-site interview where you go to meet the team. They have like the whole panel was made up of an engineer on their product, a data scientist from the data science team, and then a designer from their design organization. So they kind of think of me as someone who touches all three different domains. So they have to have all three completely different functional people to interview me. But it was actually a really fun interview.
Yeah. And how close do you work with the design team?
Right now, what I've been focusing on at Uber is that I mainly build internal data visualization platforms. So I build dashboards or web-based applications to help data scientists or engineers better understand what's the data that can help them understand the business practice. So if in that sense, I work with designers mainly on, what will be the user experience of this dashboard, for example, what will be the UX, what do we show them first, and how do they drill down of the visuals we show them, and then getting more information out of it. And that's one part of the design process. Another part is I also work with more UI or graphic designers. Once I have my kind of prototype of visualization built out, I sit down with a graphic designer who help me better, tweak the colors to be more pixel perfect, or help me, get the UI more intuitive, more like nicer looking. And then there a bit of back and forth. So like, for example, when I was doing my map, I did like a visualization of different cities around the world, and I have a designer that sit with me saying, "Oh, can you change the color to be a little green because it's not very readable?" And I will change something in my code, and then he will look at it saying, "Okay, that's good," or he will say, "Actually, make it a little bit more purple." So this kind of back and forth happens a lot when I work closely with a designer.
So you mostly use kind of internal designers to get feedback on and iterate on the final solution, but it's mostly for internal purposes, right?
Yes, mostly for internal purpose.
Interesting. So maybe what is also interesting, can you tell a little bit about the process when designing these maps? Do you have always a clear strategy from the beginning?
Yeah, so for database design, the very first step is always about, okay, what data do you have, right? You have to understand, what data you do have currently on hand, and then giving all the data input, you frame the question or frame the hypothesis, what type of answer you want your viewer to get from the visual that you designed. And the third step is that once you have the hypothesis or you have your question that you want to answer with your visuals, you go on to doing sketch. Depends on what you most comfortable with. You can do sketch by hand, or you use Illustrator or the actual sketch software to do some mock-ups. And usually it's about, okay, what color should I use, what the background should be. And then the third step, which is the most important step, is building prototypes, because every good data visualization has to be built with real data. And no matter how hard you draw, or how you draw by hand, or how hard you like in the sketching process, you think it will looks like this. Eventually, all the visual results are driven by the data you put into your code. So the whole like testing with real data, see if it works or not, it's a very long process. And then there are many different, sometimes like I call it like testing to errors. You will try many different iterations to get the final results that you like. Yeah, so those are the main process.
Yeah, that's interesting. So you sketch it out before you actually go into the data prototyping, right?
Yeah, I always do that. Sometimes I found that very very liberating, because I like to sketch a lot, I like to draw a lot, and then I like to imagine what my vids would look like beforehand. Like I would do a lot of metaphors. Oh, this visual is looking like this visualization design. Well, I want it to look like a tree. How if the tree is branching out based on for example, if I'm doing a visualization of the ancestry of your DNA, I was want to design something looking like a tree, that how it branch out into different genetic groups, and that kind of just pure imagination. It's a really fun practice.
Yeah, it's actually the most artistic part of the process, right?
Yeah. So I don't know if you heard of a data artist called Georgialopey. So basically, her whole work is about sketching out data visualization. She doesn't write any code. She doesn't use any software. She actually already published 2 books about data sketching. It's a very great book that I recommend people to take a look.
Yeah, it's interesting that you say you're structured that way, with a clear question from the very beginning. I was actually wondering if there's also some kind of experimentation with the data, which actually might lead to new insights and maybe different questions?
So the question is always doesn't change. Like, for example, when I was trying to do some visualization for Uber Pool, I know my high level question I'm trying to show is how, using my visualization, people can understand how Uber Pool traffic looks different than normal, if people don't do Uber Pool traffic. So I know that's the general question or general framing of my visuals, but exactly how to achieve that is done by sketching and building prototypes, building mockups, writing actual code to visualize real data, and that whole cycle.
Yeah, okay. So when you say you have a clear question and framing, you sketch it out, then you put the data in, but then maybe you realize you need additional data or different input to generate the answer or a different perspective. Is that something that also occurs in the process?
Oh, yeah, so that happens a lot actually. So a lot of times as a lot of times your answers cannot be answered just by sketching. You have to build it with real data, and then you realize actually I need more of this data. Giving you an example, the same Uber pool example, the first time when I only have traffic data of all the Uber pool trips for a day. That's my initial data input. And then as I was designing, sketching out, or building prototype, I realized I also need data of, the road networks of San Francisco, because I need to map my trips to a road network and using that network to calculate traffic. So then I go on to collecting the SF Open Data website. I find the actual road geometries of the entire city. And then I did some processing about projecting the trips, Uber pool trips onto road segments, and then calculate traffic.
How long is a typical design process of a map? Of one question you want to answer?
It depends on how lucky you are. But usually it takes from a couple of hours to a couple of weeks. Because the reason it's very hard to predict is because you never know what you might find, or until you write a program, you plug in the real data and you see some results. There's many times that you realize however you sketched, however your great imagination tells you this visual should look like, your final result will look completely different than your imagination. Then you have to go back to do the sketch again, now you have more understanding what is actually in the data. You have to go back to maybe change your initial design sketches, or maybe do something completely different. So that whole process will take many different iterations. And sometimes when become really clear that there's just nothing in the data you're looking for, at that moment, you might just you kind of have to admit that the initial questions will not be answered by whatever data you have at hand. It happens actually sometimes for data visualization specialists. It's just unfortunate.
Yeah. Can you tell a little bit about the stakeholders in the projects? Like main people you work for, and you already mentioned on the conference you work a lot with cities, and these are maybe some of the kind of stakeholders you work with.
The data visualization team is 40 people, and we have many different projects. So in general, we have stakeholders like data scientists. Data scientists need tools that we build to help them better testing their models and understanding patterns. We also working with our city operations teams, where we build tools for city operations to better understanding the local market. We also have a new initiative where we work with actual city planners and city government transportation agencies, where we build visualization platforms to share our Uber traffic data, to help them use those traffic data to better design city road network, for example. So yeah, those are some of the stakeholders we work with.
Mm-hmm. Yeah, I think this is super fascinating. This empowerment of decision making, essentially, for example, cities or people who design landscapes and areas.
But yeah, so right now Uber has a couple of initiatives. The biggest one, the visualization team currently working on is called the Movement.
Mm-hmm.
So Uber Movement provides anonymized data from over like 2 billion of Uber trips to help urban planning and city planners around the world to better understand the traffic patterns of their cities. The reasoning being that we want to use our Uber trip data to better empower city planners and transportation agencies to understand how their road network works, how their infrastructure works, and then better use those data to improve their city transportation networks.
Mm-hmm. Did you found any principles there or design principles that work really good for you in the process that maybe helped you over the last years to maybe become even faster or get quicker to the answering the question? Maybe also design principles in terms of visualization.
Yeah, so there are a couple of things that couple of tricks that every data visualization specialist like to play. One of them being doing animations, right? You will be surprised how much more people will be interested in your visualization if you make things move on their screen. I really like to use animations, especially to show transition changes from time to time, like how things progress throughout a certain time period. I really like to use make things move around the screen so that people can visually understand there are changes or what the differences are. And some other technique is like using building more interactive visualization versus just like just like a video or a static image. I like to give people power to click around to explore more. Definitely not overburden them with a million different kind of customizations or buttons that they can click, but just like a simple, maybe like a sliding through time. So like giving them more freedom to actually interact with the visualization will help people be more engaged into the message you want to communicate.
Mm-hmm. Mm-hmm. I think by now, everyone of the audience, is really excited to see actually the work you do, like I saw on the conference. So we put a link on the description, maybe of a conference talk you did or some of the visualizations you did who are publicly available. Can you speak a little bit about maybe what was the biggest impact you think you might had that is maybe some of the map visualizations that are publicly visible?
Yeah, one of the visualization I did, I keep talking about is Uber pool visualization, where at that time our Uber CEO was giving a tech talk about how Uber's impact, especially Uber pool's impact on cities transportation, and then he was using the visualization I did to showing like a comparison between Uber pool trip versus if people didn't take Uber pool, they all take their own ride. How's the traffic gonna look differently? So that visualization took me about 2 weeks, but it works really well to deliver the message. And then ended up he was showing it at his TED talk.
Mm-hmm. Yeah, it has a really clear and direct message, right? It's really easy to understand, I think. Yeah, we will also put that one then in the description. And maybe you can tell a little bit about the project Kepler.gl, about the mission and what it's all about.
Yeah, so Kepler.gl is an open sourced framework that I have been working on for the past year or two. It is a tool to visualize large-scale geospatial data in the browser. It's very high performance and super easy to use. It can render a couple 100,000 or to 1 million data points in the browser without any difficulties. And then give people all the different freedom of customized visualization, like changing colors, changing dimensions, and adding time animations. People have all the freedom of testing different visualization ideas with the data they have, and then creating visualization that deliver a good message. So remember before I was keep talking about how there's many different iterations on testing visuals with real data, which we built Kepler.gl just so that we make this whole testing or try and error process a lot more easier for people, so they don't have to write different programs, take a couple of days, couple of weeks to play around with their data. They can just do it all in just one tool and quickly testing different visualization ideas, and then discover insights from their geospatial data.
And what kind of data do you upload? So you upload a certain geographic data file, or does it then it gets matched with the map you have on Kepler.gl? Or like how does it work in terms of files and upload and
So when I say geospatial data, I know it's like a more foreign concept, but imagine your data sets has basically any data sets has a geolocation associated with the data point. For example, you can upload a file containing all the bus stop locations inside the city, and then Kepler.gl will just draw those bus stops as points on the base map it provides. Or you can upload a data set containing all the building footprints of your city, and then Kepler.gl will just draw it. Or you have traffic data that you collected showing how the routes that people takes from point A to point B. Kepler.gl can also draw it for you. So basically any data set with a location embedded into the data points can be visualized with Kepler.gl.
At least spatial data. Interesting. And then it gets matched with your own map, and basically the tools kind of take that data, and then there are different types of visualization of that. Yeah, this is super fascinating.
So the tool itself have different visualization types you can test it with. For example, it has this points, allow you to draw points like bus stops, or where the trees are. Or it has this geometry shape of layer, allow you to draw like polygons or lines. And it also have more like heat map type of visualization, where you just input where the points are, it will draw a heat map for you. Things like that. It also have, very interestingly, has the 3D layers, like a 3D hexagon layer, where instead of just looking at maps as a 2D representation, it allow you to add like a third dimension, like a elevation or height to your visualization. So you can looking at the map as you are looking at a physical world.
Very, very interesting. Do you know who is the main user? Is it data science, or is it actually maybe UI designers who want to create a nice visualization? Do you know who the users
are? Main users actually is data science and city operations. Designers also like to use it if they actually have the data they want to visualize. But our data scientists love to use it because they don't want to. They're not like front-end developers. They don't want to write their own program to visualize the data they have, and all they need to do is just drag and drop a CSV or a JSON file that containing the geospatial data, and then use the tool to customize it and to explore.
Yeah, I mean, if let's say you're a designer and you don't have any fancy data, can you still use it, for example, to create maybe different types of map designs? Is that possible? Let's say pre-made data you can put in there, or like maybe you can do open source data, right?
Yeah, so many cities have open data portals. Then if you find anything interesting, different city open data portals, download that and drag and drop into Kepler.gl. You can just design maps.
Yeah, Super cool. I will try it out. I think what is really interesting is that you tasted so much different design disciplines or experience in general. I mean, quite a journey coming from architecture in China. I guess it's impossible to foresee these things and predict these things back then, but let's say you would look back. Is there any advice you would give your younger self?
Um, I think if I have any advice for myself earlier, I will be telling me to, start learning programming a lot earlier, and really learning more math as well. Because when you actually at one point I realized high school math is not enough for me to visualizing, for example, how to calculate 3D projections in space. I actually have to go back to my finding the textbook around that, understanding exactly how 3D projection works, how matrix calculation works, but if I will study math a lot harder when I was in college, I don't have to go back and looking at that again. But more often, I was surprised at how much math there is to do with data visualization, and then I wish I could have, getting better at it before now.
Yeah, thank you so much, Shan, for sharing this. I think this was an incredible shout of knowledge for the design community. Thank you so much.
Thank you.
That was the episode. If you want to give us feedback on the podcast, have something to contribute to the next episode, or just want to get in touch, feel free to connect with us either on Facebook, Twitter, Instagram messages, or simply via the designdrives.org website. We love to hear from you.